Hi everyone. Welcome to today's stateful mocking session. Um, I'll get through a few housekeeping items first, and then we can get started. So the session will be recorded, and you will have access to the recording after the event. It's going to be about 25-30 minutes, and then Q&A. We have changed a little bit of the agenda because we got a lot of questions and we wanted to leave more room for the interactive part. So we'll be showing a different kind of set of demos. And yeah, that's it. Some parts we've pre-recorded just to get kind of better, clearer quality and demos, but we're here, we're online, we're answering your questions. So yeah, without further ado, let's get started. So my name is Aran. I lead growth at WireMock, and with me are Tom and Dan. Would you like to introduce yourself?
Hi, I'm Tom. I am WireMock's co-founder and CTO, and I also wrote the open source software that underpins WireMock.
Hey everyone, Dan Perovich out of the Washington, D.C. area. I lead our sales engineering and customer success programs here at WireMock.
All right, thanks for those intros. So yeah, we'll be trying to have a little bit more of an interactive session. So we'll be having a conversation. If you've got any questions, just pop them in the chat or in the questions in the Q&A, and we'll either be answering them as we go along, or we'll be answering them at the end. And of course, a lot of people did submit questions in advance, so we might start with those. So yeah, now there's a lot of different people on this session, and some of you, I know you are already using WireMock. We have some beloved WireMock customers attending as well, and some people who are maybe use the free trial or use the open source. But because we have all sorts of people online, so we're gonna kind of start with a quick intro of the basics. And really the most basic thing is like, okay, what is this problem that we're trying to solve? And the main problem that we're seeing is one of application dependencies. And maybe Tom, maybe you can expand a little bit on why this is such a challenge for testing specifically and for development in general.
Sure, yeah. So it's really common nowadays for the software that you're building to utilize services kind of outside of your team or even your organization via APIs. And this is great because you can avoid having to build functionality yourself, and you can essentially kind of outsource to some other service on the other end of an API. But the downside of this is that you then end up with lots of different APIs that you have to talk to and that you have to have some provision for in your dev and test environments. And quite often, this can mean integrating with a lot of third-party sandboxes or test environments from other teams, and they may be of varying quality, availability. They may be not always running the right version of the code. There can be sort of lots of issues associated with this. And when you've integrated with lots of them, this kind of compounds the problem. This means that the environments that you're working in may not be very stable or usable for substantial amounts of time.
And this would be, we're talking microservices as well as maybe third-party APIs. Like this would encompass both of those
Yeah,
situations.
exactly.
Okay, cool. So dependencies as the issue, and then how do we approach this problem with mocking? Like why mocking? Why is mocking a solution to this?
So there are a number of ways you can solve these problems. I mean, in a microservices environment, one option is to uh, containerize and sort of build kind of micro environments out of other services in your kind of within your estate. But that's not always a practical solution. It's simply not possible in a lot of cases. So where you have third-party APIs and you can't run the code, or if you have legacy products that you can't kind of easily containerize and use in that way, you can't do that as well. So um, mocking is about simulating those APIs in a way that gives you full control over them, and where you can own and run your mocks, and therefore kind of exert full control over your environment. And this essentially sort of decouples you from dependency on the providers of those APIs. It means that you're providing something for your app or service to talk to, and as I say, it's entirely configured by you.
Okay. Yeah, no, that makes sense. Cool. Okay, so again, we're kind of running through this section because we're assuming most people will have some familiarity with mocking. So, oh, sorry about that. So yeah, just maybe a little bit, explain a little bit about kind of how mocking works in general. Like, what is the basics of a stateless mock or a default kind of mock?
So yeah, the fundamental principle is that you configure a set of these kind of rules, I suppose. I mean, we call them stubs in WireMock, where you say if a request arrives that matches this set of criteria, then here's a recipe for providing a response. It's very simple to reason about, and by default, where mocks are stateless, the response you get is kind of entirely dependent on the request. And this makes it very easy to build mocks that are sort of good enough for whatever testing problem you have, and it makes them very simple to change. And it also has the property that many users can share a mock, and they won't kind of affect each other's outcomes. So
Right.
that's the kind of baseline stateless 101 mocking. But obviously, in this session, we're here to talk about stateful
Yeah.
mocking, which is kind of taking it a level up.
Right. Okay. So basically, the idea of when we're without state is we kind of predefine what response we're going to get, either based on the request itself or some recipe that we defined in advance. Is that correct?
Yeah.
Yeah. Cool. So yeah. So now let's talk about stateful mocking. So what is this concept of stateful mocking? And yeah, maybe go over some of these use cases that we have written here and explain why we're using it.
So it's obviously real systems are stateful, or they're nearly always stateful anyway. They they will deal with storing data, processing it, mutating it, changing their behavior uh, based on the data they've stored, all of that kind of thing. And in order for to sort of take the realism level of a mock kind of upper level, in order to more realistically simulate certain situations, um, it's necessary to sort of add statefulness to your mock. So to be able to store and retrieve data later and that kind of thing. Um, where we need to do this in practice in a mocking context is situations like where you want to test a kind of multi-step flow, and where your app won't behave correctly if, say, it writes a piece of data in one step and then tries to read it back in the next one and doesn't get the data back that it had just written. There are sort of token-based flows. I mean, this is particularly the case in sort of financial type APIs, where maybe some kind of security token will be created at some stage of the flow. I guess, kind of like OAuth authentication methods are another example of this, where a specific random token will be created at one stage, and then it will need to be um, uh, validated against or used in some way kind of later in the flow. And if that specific value isn't there, then the flow will break down, and the caller of the mock won't behave the way you expect it to. Also, if you want to use mocks to support exploratory testing, or if you want to do product demos involving mocks as well, then some stateful behavior can really help kind of improve that experience, and make it feel like this is a real live product being used by the whoever is doing the testing, or the showing the demo.
Right, because eventually you're seeing something that's more similar to real data, whereas if it was like
Yeah, I mean, a really trivial example is if you enter some data into a form and save it, then you expect that to be reflected in the app. So you expect to have added a record,
Mhm.
or updated your user profile or something like that. And if you back something like that with a completely stateless mock, then you would put in a load of data into the form, and you'd hit save, and it would go, yep, saved, and then the data wouldn't have changed. It will be whatever it was you originally configured in the stub. So so this is really about providing that basic realism around around statefulness and the state of the application you're testing, kind of reflecting the actions that you took.
Okay. And by the way, I think you skipped over this third bullet point of sandboxes. So maybe you can talk a little bit about how this comes into play in developer onboarding.
Yeah, so the sandbox is an interesting term, which I think is maybe slightly fuzzy in terms of its definition. I mean, I tend to think of sandboxes as being they're usually kind of a replica of the production system. They're usually a sort of a copy of it, and they're fully stateful in the sense that they are, they'll have a real database or data store or whatever it is that the real system does. Um, and when you're uh, so say if you have a developer portal and it has some kind of sandbox or some kind of replica of the API behind it that the developer portal is kind of showing up, then um, a large part of the purposes of that is for people who are going to be using this API to interact with it, figure out how it works, start to write code that interacts with it, and so on like that. And so um, again, I suppose it's fairly similar to the exploratory testing or demoing, really. If you're going through that process of understanding how an API works, and um, and it's responding by kind of capturing and showing you your data as you've been, as you've sent it, then it's going to be a lot easier to kind of understand and you learn to work with that API than if you have a mock, which is kind of essentially kind of behaving differently in terms of you send data to it, but then you don't get that data back again.
Okay. Yeah, got it. Cool. Thanks for that. So yeah, now let's maybe talk a little bit about how we implemented it in WireMock Cloud, because I mean, obviously, yeah, this is this is our product, and we are proud of it. And maybe you can, because I think there is some uniqueness and unique aspect to how we implemented it. So maybe you can explain this really quickly.
Sure. So a key thing about mocks, a key part of their benefit is that they're meant to be simple and they're meant to be easy to build and to change and cheap to run and all that kind of thing. And if we wanted a sort of a fully stateful simulation of the thing that we're the API that we're simulating, then we could we could provide a full sandbox of the sort I described before, where we have an entire clone of an environment, or and we see people doing this sometimes, a sort of scaled down but still sort of like fully stateful simulation of it, where essentially someone's built a microservice, with a database with business logic in it, and then they've deployed it as a simulation of a real API. And while those things are possible, they're expensive to build and they're expensive to maintain. And the purpose of mocking and the purpose of WireMock is to make it hopefully radically simpler than that, to get something up and running and to maintain it, which is good enough to support your kind of testing use cases. So the key difference with how things work in WireMock is that the statefulness is kind of layered on top of the a sort of stateless baseline. So to give a concrete example, you can start building a mock API by importing an open API, and that will give you very quickly a working but stateless mock. And then you can go in and start tweaking the individual stub configurations in there in order to make them stateful. What that means is that you can do it in the places where you really need it. So quite often you find that there are bits of an API where, for your testing purposes, it's perfectly fine if they remain stateless. But then there are parts where the statefulness is really key. So you can just focus your efforts on those bits rather than having to make the entire thing stateful from the outset, without having to sort of build a persistence layer and all of that logic kind of from the outset, just in order to make the thing work. So that's one place where we're offering a simpler and sort of quicker to market solution than building a full microservice.
Okay.
The other I suppose, key difference is the sort of longevity of state or lack of it in WireMock's case. So typically when you're testing, you tend to test the same things over and over again, and you want your starting conditions in your test to be identical. And one of the one of the difficulties with kind of building, I mean, this is true if you're doing end-to-end testing, or it's true if you're building on top of something which is kind of stateful in the sort of long-term persistent sense. You either need to build a load of tooling in order to kind of reset the data of everything back to a known starting point, so that if you run the same test suite multiple times, you'll get the same outcome. Um, or you have to have some other means to ensure that your tests are kind of invariant of the pre-existing state of the system, and you want to avoid the situation where one test run will kind of corrupt subsequent ones. So the way we do this within WireMock cloud state model is that the state is kind of short-lived. So we start with this baseline of statelessness, which sort of doubles as the kind of base the sort of reliable baseline for our tests. When we make our first request at the beginning of our test run, we haven't generated any state yet, and we will start with the mock API returning reliably a particular response, kind of at the sort of zero state point. And then as we run our test and we create state, then responses will change based on how we've configured our mocks and how we've accumulated state. But at the end of it, we sort of hit the state reset button, and all the state disappears, and we rewind back to that starting point. So this makes it a lot easier and a lot less overhead in order to get that characteristic of sort of a reliable starting point for our tests.
Got it. Okay, yeah, and then now we're gonna move on to the demos, so hopefully that will make it a little bit more tangible. So yeah, so now let's get to the kind of hands-on section. So for this first thing we're going to be demonstrating is a use case around mocking or simulating kind of Azure APIs. Dan, this is your demo. Is there any kind of context maybe you want to tell us about, like when we might be doing this kind of test?
Sure, we'll hear about it in the demo as well. But a lot of times when we're going against these cloud services like blob storage or even SQS, SMS, we don't necessarily want to start to bite into our quotas or consume the real assets, or even we want to do some load and performance testing, and we really don't want to ratchet up that spend against those endpoints, or we're just fearful if it's any third-party API that we can't reach the load levels that we need. But in case a lot of these cases, we need to maintain state. It's important that we any changes that we make in that upstream system via an API call are reflected for the subsequent calls in the future, and that's important to our application's behavior. So we'll see an example here of how we can do something like that using Azure's blob storage.
Okay, perfect. So I'm just gonna play a video. Give me one moment to get that started. One second. Okay.
On the left-hand side of my screen, you can see a Node.js application called the Azure Blob Storage Manager. It uses the Azure Blob Storage SDK in order to interact with Azure Blob Storage. On the right, we can see the Microsoft Azure control panel loaded up to the storage browser for the WireMock container in Azure Blob Storage. You can see the file listings are matching between the live view of what's inside of that storage container and what the Node.js application is currently reporting as files that are in there. And when I go ahead and I choose a file to upload, perhaps we upload this HL7 demo sheet 1 CSV file, and we click upload, we can see that that's uploaded successfully. And if I refresh in my Azure control panel, sure enough, that file is there. Now, oftentimes when we're developing or testing, and especially performance testing, we don't want to go against the live cloud services like Azure Blob Storage. This could be for any number of reasons, like cutting into our quota or making too many API calls or making them too quickly or too frequently. Or maybe we want to test some large file uploads and we don't necessarily need to go against the live endpoints. We can go against a virtualized endpoint. And we can do that very easily with WireMock Cloud, and it won't look any different than if we're going against the live Azure SDK endpoint. Now, inside of my demo app, I have a quick little toggle here. I'm going to toggle that on to use WireMock Cloud Virtualization, and we can see that it's currently reporting that there are no files uploaded just yet. Now, we can go ahead and choose some files to upload. Let's take this HL7 patient collection and upload that. And let's upload another file here, maybe of a different type. Let's go ahead and upload some CSV. Let's do the HL7 demo sheet 2 here and click upload again. And we can see that those files are uploading. But if I come over into my live view of the storage browser in the Azure control panel and I hit refresh, you'll notice that I'm not actually making any updates to the live Azure Blob Storage here. If I hover over this HL7_demo, this is sheet 1, and we did sheet 2 with WireMock Cloud Virtualization. So you can see I'm getting a realistic behavior and experience here. I can even go ahead and delete one of these, and you'll see that that works perfectly well as well. And shouldn't be, again, affecting anything in my live endpoint or my live Azure Blob Storage over here. Now let's take a look at what's going on inside of WireMock real quick here. So if I come over to WireMock Cloud and I click refresh on our request log, we can see the various different transactions that were being called to this virtualization. So if we take a look and look at this get, we can see that this was a get and it returned to 200, and here is the payload as if the real SDK endpoint was sending it back. Here's our put and the upload of the information there and what's going on, and here's our delete. So these are the various different transactions that WireMock is virtualizing and responding back. And if we look at how this is implemented, it really is just 3 different stubs inside of WireMock Cloud. We have our get, where we're going to actually look at, okay, what is the list of files that should be returned in their metadata? We have the put to handle the uploading of any of those files, and we also have the delete. And thanks to WireMock Cloud's stateful mocking capabilities, we can maintain this file list and the metadata of those files all in memory, so that when we do puts and deletes and then do the subsequent gets, we are getting realistic behaviors mirroring those of the real Azure Blob Storage SDK, even though we're not actually communicating with the real Azure Blob Storage anymore. Therefore, solving all of those challenges around increase in API calls or using up our quota or trying to go too fast while we're doing performance testing. All of that can easily be solved by using this type of approach, thanks to WireMock Cloud and its stateful behavior.
Okay, cool. So that was our first demonstration. 1 second, I'll load up the slides again. Give me a minute to work this out. 1 second. Sorry, bit of a technical issue. Yeah, sorry about that. Cool. So that was our first use case around the Azure APIs. And if there's any questions about that specifically, then you're also welcome to pop them in the Q&A, and we'll get to them shortly. And then let's look at our second one, which is maybe a little bit more complicated. Tom, is there any kind of context you want to add in advance, or should I just go ahead and play the video?
I think this sets it up quite well. I mean, essentially, this is a sort of token-based flow, like I mentioned earlier, where we're generating a token and storing it at one stage, and then we're using it later on to kind of validate, validate a transaction from a security point of view.
Okay, so by the way, I'm just looking at the Q&A. There is a question about how the actual configuration of the mock. So after we'll show this one, we have a kind of a little demonstration of a new feature we have around configuring a stateful mock. So hopefully that will give you some idea of that.
This next demo as well does go into some detail about the configuration of the mock. So you'll see a little bit of that, but
yeah,
we
we
can go
just
into a bit
wanted
more
to keep
detail
it a
later on.
bit shorter, and we will also, we can send after the event, we can send some other materials that we have in previous sessions that we have done more of a step-by-step tutorial. Okay, so let me just go ahead and share that video. 1 second. Yeah.
Going to quickly demo a stateful mock API that shows a kind of a token-based workflow. So this emulates a common pattern used by kind of banking and financial apps, where they'll send you an SMS with a one-time PIN or code in it that you can use as an extra level of authentication when you're trying to do something sensitive, like making a payment or a charge. So I'll start by explaining how this stub works. So we start by creating a charge. So this is a stub that accepts a post, and there's quite a lot happening here. So I'll break it down. So first of all, we validate that we get a request body that matches the structure that we need. So with the amount, the currency, and the customer ID that we're using for the charge. Then we store this charge data. We kind of create a charge object that we can fetch later, and crucially, we create this 6-digit numeric one-time PIN, and we store that as well. What happens then? So we return this charge data. So this is kind of the input parameters that we provided, and some synthesized parameters as well. So a status and a date. I'll show you that in a moment. And then, most importantly, we then take the one-time token, the one-time PIN, and we fire out a webhook to another service. So this is, in this case, a very simple mock, and it's another mock API, which is also stateful. It's simulating something like Twilio, where you can make an API call to it, and it will send out an SMS to someone's phone. And so we create this charge. The webhook triggers the SMS to be sent. And then we can go and retrieve the charge and see what state it's in. It will be in a pending state initially. And then we have the option of authenticating the charge. So taking the token that we were sent and going through the second step of authentication. And if we put the right code in, the charge will succeed. And if we put the wrong code in, then it will fail. So let's run through this very quickly. So I'll open up the test request maker, and we'll say that we want to send $101, and when we hit send on here, excuse me, we see we get a 200 response with this JSON payload, which is the parameters that we input plus these synthesized parameters, and the crucial one here is this pending status. We now go and grab the generated ID of the charge we've just created. Let's save that for later. We can go and fetch it first of all, so we can go and make a GET request to this same ID that we had before, and we get the same data back. And you see it's still in this pending status. We can also go into the request log, and we see from this charge transaction that we made, you can see how it's storing the data here, so you can see the effect on the state that was made by this stub, and also we can go and look at the webhook request that it made. So this is the interesting thing. So it generated this token and fired it off. Now, as I mentioned, we have this other mock API, this demo SMS mock API. If I go and refresh this, it should show me the latest token that was received. So now I can take this token and I can use it to authenticate the charge that I created. So if we go back in here, and it doesn't matter which of these two we use, if we say let's authenticate the charge that we created earlier, and we'll use the correct token, the one that we just got from our smartphone, and we get this message success. And now we should be able to go back into the read endpoint with our saved ID from earlier, and we now see that the status is completed, and status is complete, and we have a completed date added on. So just to prove that this is kind of working dynamically and that it won't accept just any code, let's run through the process quickly again. So we'll make another request, let's say £202 this time. So we fire that out. We've got a new ID for this charge. And I'll skip over fetching its status this time. We should now have a new SMS. So this is the correct one, but actually I think we this time round we would like to get it wrong. So let's go in here again. Doesn't matter which of these two we're using. We're just using it to pre-fill the test request maker. Let's put our ID in here, but this time we'll put something in which we know is not the ID from the that we saw appear on the phone. We hit send. This time it says failed, wrong one-time pin. And if we go into here now, into our getter, and we make a get request for our charge ID, we should see that it has the status of failed.
Okay, so that's that part. I'm going to, and yeah, that's our second demonstration. I think in terms of what we have next is really that's kind of the end of most of our content for this webinar. We will get to questions immediately, but we do have a kind of special surprise. We have a brand new WireMock cloud feature that we're unveiling today. Maybe Tom, we're running a bit late, so maybe run through that as quickly as you can, so we have room for questions. But yeah, you can go ahead and share your screen.
Sure. Yeah, this one should be very quick. Let's just. Can you approve my screen share? Thank you. Okay. Can you see that okay? So what I'm about to demonstrate, so all of the things that we showed you in these demos, the using the stateful features kind of involves configuring it yourself. So going and taking stubs you've recorded or whatever, or building them from scratch, and then kind of adding the stateful templating expressions on. And what we realize is that there's at least one really common pattern that you're likely to implement over and over again with this, which is kind of where you have a set of sort of REST endpoints that are doing the kind of essentially the kind of standard CRUD operations, so where you can post to create something and then do a get to read it back by ID, read back a list, and so on like that. So we've kind of set about creating a wizard that lets you automate that just by kind of providing examples of the input and the kind of resulting state. This is the reason I haven't pre-recorded this is that it only made it into production a couple of hours ago. It's under a feature toggle at the moment, so it's not immediately available, but hopefully we'll take the toggle off in the next few days and then it'll be available to play around with. I'll very quickly run through this. So essentially, so all we're doing is we're providing kind of the base URL for the collection of items. So if I say this is just v1 users, and then I'll give an example of what a user looks like. So this is our input. This is kind of, if we're creating a new user, this is what we're posting as our input. And then we give an example of what the resulting output. So again, it's like the example in that previous video where you kind of have the input data and it's enriched with some synthesized values. So so it will have an ID, it'll have the name that I supplied, and it will maybe have a created date. And then we hit create, and you'll see it's generated all of these stubs. So there's the ability to create, update, delete individually, delete collectively, list all of all the resources in this set. So it also generates the open API. Actually, I've opened this already, haven't I? So you see it generates the open API and generates the documentation in addition to sort of generating the stubs. So I can very quickly demo this. So this is the post endpoint. And there's this example that I typed in the first place. So if I say send this request, and you'll see it's generated an ID and attach the created date on there. And then I can go to this list users endpoint, and you'll see that the record that I just created is in there. I can go and do another one, put Dan in this time, and then go back to the list endpoint. So now we have two records in there, Dan and Tom. And I can let's go and delete them all, shall we? Yeah, I can do that, and then they're all gone again. Hopefully that gives the idea. I haven't demonstrated all of them because we're a bit short on time. But what this does is really kind of short circuit the process to getting the most common use case for statefulness up and running. And as you can see, it's pre-generates all of the templating and ID generation and all that stuff that you'd otherwise be building yourself. So hopefully a huge time saver.
Okay, that's really cool. And yeah, if there's any other questions or anyone wants additional details about that, we'll definitely, first of all, you're welcome to ask, and we'll definitely be releasing a blog or a video about it soon because it's very cool. So yeah, let's do questions. Now I don't think we managed to get to all of them because we did get like about a dozen even before the event, and we've got a few that we want to answer now. But yeah, let's just get started. So we have a question from Boyd about the differences in implementing in unit testing versus end-to-end testing. So Tom, do you want to take that one?
Sure, yeah. So I think that kind of gets to the heart of what we're trying to do with the stateful mocking. I mean, when you're using mocking in a unit testing context, I think the right way to use it is to build each test, to treat a unit as kind of a unit of work as well. So kind of a single interaction or a single state transition. And by doing that, that means that you can get away without using more advanced features like statefulness generally. And you can kind of inspect the behavior of your app sort of one state transition at a time. Whereas conversely, building end-to-end tests, you often end up with these kind of multi-step interactions happening, particularly if you're testing kind of combinations of services working in collaboration with each other. And that's when I think two crucial things. One, but having data which is kind of in alignment with the other data in the system. So where referential integrity is important, you've got data pre-configured which is aligned with other data, and then the other one is modeling statefulness where necessary, so that you can go through those sort of multiple steps in a test, those multiple state transitions, and get this kind of consistency of behavior.
Okay. So yeah, we got a question about handling stateful mocking for external APIs that are changing frequently. Dan, maybe you can take that one. You're on mute, Dan. Classic Zoom.
Yeah, absolutely. Yeah, so this is a great question. Thanks, Shilpi. I think that this is always going to be a challenge, right? As our upstream APIs that we're mocking are constantly changing. I think the best recommendation here would be to lean on the validation features that are built inside of WireMock Cloud. So regardless of whether you're using state or not, if we can have an accurate representation of the API, the live API, typically today represented as an open API specification, we can make use of WireMock Cloud's capabilities to validate that the responses being generated by the mock API still conform to that open API specification. So the recommendation here would be to kind of couple these two things together, right? You build your mock API as the accurate representation of today's live service, upstream service that you're trying to virtualize, and then also supply the open API specification document and keep that in sync with the most current version, perhaps using our Git sync features built into the product or our APIs to programmatically retrieve that open API specification so that requests coming into the mock API and the responses being generated by the mock API are consistently validated against the most recently released open API specification. That way you'll be alerted to any drift that might be happening from your mock API and the live service.
Okay.
If I could just add
for-
something to that as well, the thing I just demoed, one thing I forgot to mention about that is our future plans for that include also being able to take an existing set of non-stateful stubs, including ones that you may have created from a recording, and kind of making those stateful. So in the longer term, I mean, this is what we hope this will allow you to do is use re-recording as a means of keeping your mocks up to date. So if the real API is changing on a regular basis, then you can simply re-record and we will regenerate the statefulness for you as well, rather than you having to kind of go and repair it each time.
All right. Cool. So I'll keep going.
So I've just spotted this question from Paul at the very bottom of the Q&A. I know I'm probably completely usurping the order here, but I thought this was a really good question
Go for it.
about thread safety of state. So yeah, we very much designed this with concurrency in mind. The way state is modified is in essentially a kind of optimistically concurrent fashion. So when you set a state, you can you set it in terms of the previous state. So for instance, if you're incrementing a counter and two people incremented at the same time, then what WireMock will do is kind of back off and reapply transactions kind of in a sequential way where they collide. So it's absolutely intended to be thread safe. So where you have multiple concurrent operations happening and affecting the same state, it should behave in a consistent way.
Okay, cool. Hopefully that answers Paul's question. Right. So to keep going, there's a question about can you pull state from a database?
Sure, I can take that one.
Go ahead.
So yeah, this is a great question. So today, the state engine is, we need to define that state. Typically, we're doing that, in a post, as you saw in some of today's examples. When we're talking about interfacing with a database, we do have a feature that is tied to our data sources, which would allow us to retrieve information. Today, it's available to everyone from a CSV file that's uploaded. So you could load some the initial state if you wanted to from an uploaded CSV file. If anyone is interested in a feature that we have in closed beta right now, we are allowing customers to test connecting data sources to a real ANSI SQL database to make live queries against those. So you think of Postgres, Oracle, MySQL, SQL Server style of databases. This is, there is a little bit of setup that requires the connectivity to be set up. So that's why we request that if this is of interest to you and connecting to a live database with our data sources feature, that you reach out to your customer success team or your account executive, and we can set up a short call to cover off on your requirements. So yeah, you can couple these two together, but typically they're looked at as two separate features. Right?
Okay, yeah, thanks for that. So I see there's yeah, maybe let's take one more, which I guess is just kind of a general WireMock question, but worth answering nonetheless, which is at what stages of the SDS software development lifecycle would we be using WireMock? Is it for system testing, component testing, integration testing? And yeah, how do you kind of approach that? So I think, Dan, we intended for you to answer the question, but whoever wants to.
Yeah, I'll take a stab at it, and I'll
Yeah.
put his spin on it as well. But I would say, absolutely across all stages of the SDLC, except production, right? As that it's still part of that life cycle. But there's use cases across everything, right? So in development, obviously, we need to solve for a lot of upstream APIs that are not available, don't have the right data. Can't give us back the error scenarios that we need to code and test our error handling logic and retry logic. So, those types of use cases present themselves in all of the pre-prod environments. So, in system test, we're going to have a hard time replicating or asking any third party to send bad data over the network to us. So when we need to test those types of edge cases and rainy day scenarios, we're going to have that type of testing across all stages of the pre-prod, testing. Load and performance, again, is another heavy place where we're going to use mocking capabilities and virtualization capabilities, and that's these stateful things that we were showing today, because we can't often get access to environments, even internal environments, and especially third-party environments, to handle our production load level. So we can certainly have these stand-in virtualizations to achieve those high levels of load. Now, when do we not want to use virtualization and stubbing and mocking? Now we're talking maybe classic UAT testing, those last gates to getting into production, where we have real users coming in. We want to make sure that we don't know what order users are going to send their traffic. It's not repeatable. We want to ensure that when they start sending in really malformed information in the boxes of our application, that all these things are being handled. So all the way in that UAT testing and final integration tests, especially at those lower load levels, that's where we'll want to make sure we're going against the real APIs. But all of those other stages of the SDLC, there's going to be very, very good use cases for using the mocking capabilities of WireMock Cloud. Tom, anything you'd like to add there, or
yeah, I suppose just to reinforce your point, I think the way I look at it is that mocking would never completely replace integrated testing. I mean, you have to do a certain amount of that, but the way we would recommend that you use this is that you use mocking for the things where you can, for the cases where the risk that you're trying to understand through testing can be sort of adequately understood that way, and by doing that you can radically reduce the amount of sort of integrated testing that you need to do, and I think this involves kind of getting into a mindset of separating types of risk. So what do I really need to test in a sort of fully integrated way in order to really gain confidence, versus what can I test with some dependencies mocked and some real, versus what can be tested in a very sort of decoupled, isolated way. And I think if you take that sort of segregated view of things, then you can radically reduce your dependency on the sort of heavyweight integrated testing approaches. You can have fewer environments. You can spend less time, sort of in build and in testing generally, kind of running things against slow, fully integrated environments.
Okay, cool. That hopefully that answers the question. I see we do have one question that we kind of dismissed accidentally by Suman regarding mocking an identity store, but honestly, I think maybe we should take that offline because it's a little bit more specific, more complicated.
It's worth mentioning we do have
Okay.
a sort of generic OpenID Connect mock that is published in the template library, and there's some documentation about it as well. So there is already some stuff on our. In fact, we published a blog post about it recently as well, didn't we? Integrating it with Spring.
Yes.
So yeah, we have demonstrated that you can build an OIDC provider on WireMock, and I believe Enter ID is OIDC compliant. So in principle, it should be possible to sort of fairly trivially adapt that mock to the sort of specifics of how Enter ID does it.
Yeah, so if someone's still online, I've not checked, but if they are, then hopefully that answered the question. And you're welcome to check out our blog. We recently published something about mocking OAuth in Spring Boot, and that's what Tom was referring to. Cool.
There is
I think
also a template in WireMock Cloud for this, by the way, so you can spool it up that way as well.
There you go. Cool. So I think we'll stop there. Thanks everyone for joining. I'll just end with like a quick sales pitch, which we've not done. So yeah, we are WireMock. You can find us at wiremock.io. You can sign up. We have a free forever edition for developers to tinker with, and when you sign up for that, you get 30 days on our enterprise edition, where you have access to stateful mocking and all the cool features of WireMock, which is kind of enterprise grade virtualization and mocking, and you saw a bit of it today. If you're already using WireMock, if you're a customer, if you're evaluating, if you're using the free version and you have any questions about anything we covered today, then please don't hesitate to reach out either through the intercom in-app chat or through our website. You know where to find us. Otherwise, yeah, I think we'll end there. Thanks everyone for joining. Thank you, Dan. Thank you, Tom, for today's presentation. And yeah, see you next time. And yeah, keep a lookout for our email. We'll be sending you some more information. Oh, okay, I see this was answered. We'll be sending you some more information about WireMock's stateful mocking and other stuff. We'll be sending that tomorrow, probably, or yeah, early next week. Thanks again, and bye, everyone.
Thank you.
Thank you.